Diane's second-year algebra class is beginning a 5-week unit on polynomials.
Take a minute, relax, get into the math zone. Today you're going to start your polynomial lab. You did a reading before this, looking at the vocabulary, the terminology. You know some of the stuff. You know what I mean when I say polynomial, the word polynomial. It's all on that vocabulary sheet.
The first assignment is an open-ended lab investigation designed to engage these 11th and 12th graders in grappling with underlying concepts.
Today they got their first definition of what a polynomial was, and they're being asked to investigate something they've never seen before.
You guys took good notes the last time you did the lab, and you want to keep taking good notes this time so that we have documentation of what you did and how you discovered what you discovered. And you're going to need your graphing calculators today. I have a few extras. A copy of the lab is coming around to you right now.
After completing the lab, Diane's students will be able to apply what they're learning about polynomial functions, not only to predict the shape of the graphs, but to use algebraic techniques to solve complex equations.
So you'll notice that I've started this time with a definition of a polynomial function. If you just take a look at that definition for a minute.
In a traditional classroom, this material could be covered in as little as 2 weeks. Devoting 5 weeks to the unit, including a whole week in class to the lab activity, Diane hopes her students will be better able to master the skills she is assessing: mathematics communication and problem solving.
It's a little scary to say, I'm going to take 3 days to let you investigate what I could tell you in 20 minutes. And I couldn't do that if I didn't think the payoff was there. Because, yeah, if I were going to tell you those things in 20 minutes and then do 2 days of other stuff, I could fit more stuff in. But that's at the risk of you missing the 20 minutes of stuff that I really wanted you to have and to hold on to.
Why do I feel like I've never seen that before?
That's a good question. You haven't seen it before. In this case, I've given you equations that I want you to try. Graph them, see what happens, see what you think is going on there, try and figure out why what's happening is happening. If you want to sit on your own and come back to the group later, that's fine. If you want to talk with others and work through step by step with a couple of people, talking out what you're seeing, that's fine too. Okay? Let's go.
Especially on a day like today where they're doing a lab, I don't want to talk for more than about 5 minutes. I want them to get going and thinking, because there's a very clear expectation that I want them to see that they're doing the work. You should be finding that all polynomials of even degree make a U shape and all polynomials of odd degree make an S shape. I could have told them that. I could have listed everything that was in that lab at the beginning of class in about 10 minutes and then made them do 30 problems. But they would be memorizing it rather than understanding it.
What should be our limits?
Whoa. What did I do?
So why is this n-1 and not like n-z or something, or 9 or blue?
That's a good question too. You start with the highest power of x.
Right, okay.
And the next term that follows is going to be the next highest power of x, decreasing by 1. You're not going to have any exponents that are decimals or fractions.
Right.
You're only going to have counting numbers.
Right.
Why does it go right from 7 to 0?
Because you don't have those other numbers in between. It just, you go from highest to lowest with the numbers you have.
Right. And specifically, if there's no x to the 6th showing, what's the coefficient of that term?
If there's nothing there, then it's 0.
Right. So I could write this if I wanted to as 1/2 x to the 7th plus 0x to the 6th plus 0x to the 5th plus 0x to the 4th to fill in the spots. And so there technically is a term in every one of those spots. We just don't write them because it's a waste of time.
Right, okay.
So it's the same.
The lab that we did today is one of 3 that they'll do this semester and one of many that they'll do as students in Division 3. And each time they do that, they'll get a little better at being autonomous in their investigation, at knowing the conventions of formal mathematical notation, at understanding what proof looks like and what constitutes real proof rather than anecdotal evidence.
I don't think that would matter.
It might.
They're positive or negative this time, maybe.
Yeah, maybe that.
Today in class, the lab that we're doing now is just having, I don't want to call them questions. It's really just to prompt your thinking. It's to start you off saying, well, what happens when you do this and look at this trend? And sometimes it'll give you hints like, you know, pay attention to the x-intercepts or something like that. But it's really just like you would do with any lab, take observations and then draw logical conclusions.
I don't understand.
Wait, stop.
What are we looking at?
Oh, wait,
Oh, there we go. What's up?
What number is that?
So can we do that?
Well,
Can we zoom out?
if you see, the thing is, you can't see the curve because it's so.
Well, I don't care. I just want to see it going down. You know,
Okay,
the
and
other.
then you go to like.
They say, okay, we'll change this, change that, and you're not, I mean, Diane doesn't do it in front of the class for, she doesn't do it on the board for us, which, I mean, I am not a fan of math, and I would probably, pay no attention to it and be much less involved in it if I wasn't doing it myself, which is why we need each other and why we do that thing where we all cluster, because if you get confused, you need your friend to, like, oh my God, Catherine, what's going on? It's getting bigger.
There you go. There you go.
This is
You
like
win.
Catherine was talking about, look, they do straighten out.
But see, it's because you're looking at you so far away. No, if you get
That they appear to be straight.
Yes. If you're really close to them, they wouldn't be.
Yeah. So you're telling me they're not actually straight?
They're not.
Thank you for shattering my reality.
Yes.
let's see if it doesn't see.
Why don't we use a smaller number?
Why don't we use an odd number?
Yeah, odd numbers do the S.
Why? Why do they do that? Why is it different? I'm writing it down right now.
Smaller. It's not going down. It's going up.
It's easy if you only look at what happened today and think, okay, every day there's an investigation happening, and apparently this woman never says anything to her kids about how to factor or how to do this or how to do that. And in fact, you could come into my room and see very normal looking days where I do what teachers the world over do. I show a problem, I do a demonstration, and I have them practice. But it's always with a different purpose in mind. The kids know when they're learning that, they're trying to acquire a skill that will come in handy when they want to apply it to something. They're not looking at it as an end in itself.